So this is a presentation as a part of assignment submission to be done for AI product management course by Duke Fuqua University. So the topic of the presentation is power plant output prediction. So the problem statement is we have to predict the power output of a combined cycle power plant using AI model, and I've used Python as a programming language for pursuing this assignment. So the approach for solving this particular problem is to go through the entire data set, and first step is to clean the data to make sure the data does not have any errors or inconsistencies or any outliers. So I have done exploratory data analysis, and I have tried to clean the data and make sure the data makes sense, and it is fit for pursuing uh, an AI/ML model prediction. So the overview of the data is that the data consists of 9568 hourly observations, and the features for the combined cycle power plant project which are going to be used as AT, that is temperature, AP pressure, RH humidity, and V is vacuum. And the target would be to predict the power output, uh, and the power output values range from 420.26 megawatt to 495.76 megawatt. So the findings of the exploratory data analysis is that after cleaning the data, I find that there are no missing values, and I find that there is a strong negative correlation with AT. uh, the value to be exact is minus 0.948, and V, that is minus 0.870, and there is a moderately positive correlation with AP of value 0.518 and RH 0.390. So strong negative correlation with AT and V means that as AT and V increases, the power output decreases, and vice versa. And moderately positive correlation with AP and RH means that as AP and RH increase, the power output or the power output generation moderately increases as AP and RH increases. So the AI/ML models which I have which I have used for pursuing this particular assignment is that first I have tried to use linear regression model, and then later on I have also used a random forest regressor. And the results of the linear regression model is that with the linear regression model we get an RMSE root mean squared error of 4.5 and R square value of 0.9301, while whereas while using random forest regressor model, we find a root mean squared error of 3.24 and R square of 0.9637. It means that the error factor reduces when we pursue this problem using random forest regressor, and whereas the R square, that is the accuracy of prediction, increases from 93 to 96% when we use random forest regressor as compared to linear regression model. So the summary or the findings of the combined cycle power plant project is that the dataset has 9568 observations and has 5 columns, that is ambient temperature, exhaust vacuum, ambient pressure, AP, RH relative humidity, and PE power output target. Missing values, there are no missing values in any of the columns, and correlation analysis is that power output is highly negatively correlated with AT with a value of minus 0.948 and V of minus 0.870. Power output has moderate positive correlation with AP of 0.518 and RH of 0.390. The heat map visually confirms these relationships. So to further add to the summary, the model performance comparison is that linear regression model has a root mean squared error of 4.5 and R square value of 0.9301. This indicates linear model explains about 93% of the variance in the power output, but errors around 4.5 megawatt on average. Whereas when we pursued this problem statement using random forest regressor, we found that the root mean squared error reduced to 3.24, and the R square value increased to 0.9637. It means that the random forest model reduces the average error to about 3.24 megawatt and explains 96.4% of the variance. So visualization, the scatter plot of actual versus predicted power output for random forest model shows most points clustered along the 45-degree line, confirming strong predictive accuracy. So from the findings of pursuing two AI models, ML models for solving this particular problem statement, we find that the random forest model is perfect for solving this problem statement, and the random forest model outperforms simple linear regression, achieving a low root mean squared error and a higher R square. So what are the next steps? So what we can do is that we can further tune the random forest hyperparameters like maximum depth, minimum sample leaf, or try other algorithms like gradient boosting to possibly improve the accuracy. And feature engineering can be done, for example, polynomial features or interaction terms and cross validation to ensure stability is also recommended as further next.